Great. So welcome to the Coin Atlantic webinar series, Coastal and Ocean Data Management Best Practices. This series is aimed at empowering ocean research users to help increase and improve their organizational data management capacity for projects in the marine and coastal environments. Today's webinar will feature the Digital Research Alliance of Canada, which is a national nonprofit organization which works to harmonize and improve access to digital data tools and services for Canadian researchers. My name is Shen. I am the project officer for Coin Atlantic. And before we dive in, we would like to acknowledge that we at Coin Atlantic respect the Indigenous peoples on whose traditional territories our work is conducted. We strive for respectful relationships with all Indigenous peoples as we search for collective healing, true reconciliation, and honoring these beautiful lands and seas together. I am currently on the traditional and unceded territory of the Mi'kmaq, and we encourage everyone to include their own land acknowledgements in the chat. Now I'd like to pass it off to Alexi to introduce the Digital Research Alliance of Canada.
Hello, everyone. Good afternoon if you're in Atlantic time zone. My name is Alexi Backerdax-Westcott. I'm Executive Director with Coin Atlantic, Coastal and Ocean Information Network Atlantic. I'm currently located in Mi'kma'ki, the traditional and unceded territory of the Mi'kmaq people. I'd like to welcome our guests today, Nichole DeMichelis, Robyn Nicholson, and Tamanna Moharana from the Digital Research Alliance of Canada. So now if you would like to start your presentation, that would be great. Thank you so much for joining us today, and we'll just wait for you to share your screen there.
All right, hello, and welcome. Here we go. So my name is Nichole DeMichelis. I am a data curation officer with the Digital Research Alliance of Canada. I'm going to be presenting today alongside two of my colleagues, Robyn, who is our data management planning coordinator, and Tamanna, who is a fellow data curator. So just making sure we're all starting from the same baseline. When we talk about data research, what are we talking about? We're talking about data that are used as a primary sources to support technical or scientific inquiry, research, scholarship, or creative practice, and that are used as evidence in the research process and or are commonly accepted in the research community as necessary to validate research findings and results. So we're talking about all the bits of information that support scholarly research. And when we talk about research data management, we're talking about a wide range of practices and procedures that are applied through the life cycle of a research project to guide the collection, documentation, storage, sharing, and preservation of research data. So it is an ongoing joke in RDM that you can never get through an RDM presentation without this image of the research data lifecycle, because this is such a huge part of how we work. So research data has a life cycle that develops alongside the research, typically starting with your data management plan, and Robyn will talk about that in a minute. The collection or creation of data, its processing and analysis are sometimes referred to as active data management, as they typically occur during the research project. As a data curator associated with a repository, I tend to see data at the sharing and dissemination stage, and we collect it with and we deal with its preservation and potential reuse. That said, none of these stages live in isolation. In reality, all of these steps will inform each other right from the very beginning. By keeping future reuse in mind from the planning stage, we work to make data findable, accessible, interoperable, and reusable, or FAIR for short. Good research data management ensure that data are stewarded in a way that enables and enhances future reuse by humans and machines. So we often use these FAIR principles to sum up the goals of research data management practices more broadly. In order to get as much value from data as possible, we need to be able to reuse it. And if we can't find it, we can't reuse it. If we can't access it or don't know the conditions under which we can access it, we can't reuse it. If we can find it and access it, but then can't read or process or analyze the data using the kinds of software and hardware that are available at the time, then they're still not useful. So all of these three things, findability, accessibility, and interoperability, go to inform the reusability of any given data. So why are we so excited about research data management? What value does it bring? We have these lofty goals of open science, value added, cost reduction, and reproducible research. And of course, these are very important goals. But in the day-to-day, often what we're talking about are our immediate goals, which can be to save time, money, and headaches during your research project or at the time of publication, to ensure our data management practices reflect the requirements laid out by research ethics boards or consent forms or laws, increasing research impact as findable data is more cited, and satisfying funder and publisher requirements. An increasing number of funders and publishers are requiring that researchers commit to depositing or sharing their data. And some funders also are requiring that researchers indicate how they're going to manage their data through the research lifecycle in their initial applications. So now we're talking about our friends, the tri-agencies. In Canada right now, the big funder requirement that has come into play in the tri-agency is the tri-agency RDM policy, which came into effect March 15th, 2021. So this policy has three components, one for institutions and two for researchers. Institutions have to create an RDM strategy, and researchers will have to submit data management plans or DMPs, and will have to deposit the data, metadata, and code that supports their publication. The policy is being rolled out in phases, but it's likely that the first element you'll see as a researcher is the requirement for data management plans in the applications for funding. And while it might not be in all of them, I can assure you that it will be soon in most or all. So to shepherd us on that journey, I will hand this over to Robyn.
Thanks so much, Nichole. Let me just request control the slides here. Perfect. All right. So as mentioned, I'm Robyn Nicholson. I'm the Data Management Planning Coordinator with the Digital Research Alliance of Canada, and I'm very happy to be presenting to you today, taking a dive into DMPs or data management plans. Diving right in, let's tackle the obvious questions. What is a data management plan? Why is it important? And when should you write one? DMPs are one of the foundations of good research data management. Put simply, a DMP is a formal document which clearly articulates the strategies and tools you will implement to effectively manage your data. Speaking to the management of your data, both during the active phases of your research and after the completion of your project. Ideally, a DMP is treated as a living document that can be modified throughout your project to reflect any changes that have occurred. And the overall objective is to address issues related to data management prior to starting your research project. So why are DMPs important? For starters, writing a DMP is good data practice, an established international best practice even, because it helps you think ahead and map out how you will manage, describe, analyze, store, and share your data. DMPs are also practical. A DMP provides you and others with a record of what you intend to do from the very beginning, and a reminder of what you intended to do in the first place when you revisit it later on. And if all of that sound reasoning isn't enough, as Nichole kind of mentioned earlier, forewarned, DMPs will be required or already are in some cases. DMPs are one of the three main pillars included in the recently released tri-agency research data management policy. So in the spring of this year, which is quickly approaching, and actually I think we're already technically into spring 2022, the agencies are going to start identifying the initial set of funding opportunities that are subject to the DMP requirement. But in the meantime, the Alliance is focused on making DMPs as straightforward and as unburdensome as possible for researchers via the development of guidance, resources, supports, and tools, many of which I will cover a little later in this presentation. So digging a little deeper, DMPs are important to the research process because they can help you to set out consistent strategies prior to starting your research, allowing you to map out how your data will be managed throughout its entire life cycle. A DMP can also help identify strengths and weaknesses in your current research practices and help to make decisions on how to adopt more effective data management practices. DMPs can also help you prepare your data for future reuse, preservation, and sharing. And finally, DMPs can even make financial sense. Beyond helping you to acquire funding, planning your research can help you to plan for and reduce overall costs of your research by improving project efficiencies and data management practices so that your research is supported in the active phases and long-term after the project is complete. So here we have yet another research life cycle. Having covered the what and why, let's talk a little about the when. Research data management in a broad sense refers to the management of data throughout the phases of the research lifecycle, and a DMP starts at the very beginning in the planning phase of your research as you start to write your proposal, apply for funding, and starting up your project. A DMP also speaks to the management of your data through the active phases of your research, from collection, analysis, and sharing of data through to the end of the project. And finally, as a living document, a DMP extends beyond the planning and active phases, remaining useful well after the completion of the project through preservation and discovery. So now let's dig into what actually goes into a DMP. As mentioned, a DMP provides information across key research lifecycle categories. While there can be disciplinary differences between DMPs, generally they cover the same key aspects of research: data collection, documentation and metadata, storage and backup, preservation, sharing and reuse, responsibilities and resources, and ethics and legal compliance. My colleague Tamanna will be taking a deeper dive into many of these aspects in the presentation to follow. So for now, I'm just going to give a quick overview of what kind of information from each of these categories you would likely include in DMP. So starting with data collection, in your DMP, you can include a description of how you will collect your data, including sources and formats, provide an estimate of the amount of data you will collect, describe any software or platforms that you will use for data collection, outline how you will both store and transfer your data in the active phases of your research, and explain how you will organize your data. That last one isn't popping up. Oh, there we go. Explain how you will organize your data, including the file naming and version control. Moving on to documentation and metadata, your DMP should include a description of what information will be needed for others to understand or to reuse your data, how you will consistently capture documentation throughout the project, as well as your choice of a metadata standard suited to your discipline or chosen data repository, or alternatively, your rationale for creating your own. For storage and backup, your DMP should provide an estimate of storage space needed during the active phases of your research, also remembering that as your research progresses, your data is likely to grow. You should also state a data backup schedule, ideally automated, that will avoid any tragic data loss. And you should also outline how collaborators or your research team will access, modify, contribute to, and work with your data. As you start to think more long-term about your research, consider that not all data that you create will necessarily need to be preserved. Consider the possible enduring value of your data and your funding requirements to decide which, if any, of your data should be preserved. and document these decisions in your DMP. As with any aspect of research data management, there is always someone out there to help, often at your library, so consult with experts in the libraries as needed. You'll also want to consider optimal file formats, optimal file formats for supporting long-term preservation. Optimally preserved data are easily accessible and used by anyone without requiring proprietary software. For sharing and reuse, consider what the appropriate sharing of your data looks like, being aware of any funding or confidentiality requirements. Explain what uses can be made of your data in your DMP, and consider the application of a Creative Commons license to make it clear to others how your data should be treated. Your DMP should also include your choice of data repository appropriate to your data, your research, your discipline, or methodology. You can consult with colleagues or librarians to help in this decision, and you can also use re3data.org, which is a very helpful, searchable registry of research data repositories. You'll want to choose a repository that assigns permanent identifiers to datasets, like a DOI or digital object identifier, for example. This will enhance the discoverability, accessibility, and citability of your data. And finally, if applicable, describe how you will ensure file integrity, anonymization, and de-identification, particularly in the cases with possible sensitive data. For responsibilities and reuse, your DMP should identify the data stewardship roles and responsibilities of your project members and other organizations during and after your research. In other words, articulate who will do what in relation to data management throughout your project. You should also estimate and describe any required resources and costs for data management during the active phases of your research, as well as the cost to provide long-term access to your data after the project is complete. And last but not least, your DMP should describe if there are any legal, ethical, or intellectual property issues related to the collection, management, and sharing of your data. You should explain how you will comply with any applicable privacy legislation, funding, and institutional requirements, and describe how you will ensure your data are securely managed after the project is complete in accordance with any ethical obligations, including management of sensitive data. So taking a step back from the content itself, let's go over a few general guidelines for writing your DMP. Start simple. Begin by providing a description of your research project, its focus and purpose. Provide clarification for any acronyms used. Avoid discipline-specific jargon as much as possible, as your DMP should be easily understood by anyone. Avoid leaving sections or questions blank. It's true that not necessarily every question will be relevant to your specific research project, but in that case, at least ensure that you provide rationale for why that section or question does not apply. And while you're at it, provide rationale for decisions in general. Help others understand why you have made a decision. And finally, remember that your DMP is a living document to be updated as needed. In terms of the length of your DMP, it will often ultimately depend on the complexity of your research and your institutional or funder requirements, though generally anywhere from a page to a few pages is standard. Writing a DMP at the start of a brand new project might be a little time consuming, but remember that often the content you cover in your DMP can also apply to your funding applications or ethics board approval processes, so you can reuse and repurpose answers to questions you've already thought about. And for subsequent research projects of a similar nature or for the same funder, you can recycle and adapt content for new projects and new DMPs to help save time. And for these last few minutes, I'm going to point you to some existing DMP supports and resources that will build on what I've covered in today's introductory presentation and further help you in writing your DMP. First off, Alliance RDM, previously known as the Portage Network, offers 3 foundational documents, 2 brief guides and a primer on DMPs and how to create an effective DMP. And once you're ready to start building your DMP, you can consider using the DMP Assistant, which is a national, open, bilingual data management planning tool that helps researchers better manage their data throughout the lifespan of a project. The platform is hosted by the University of Alberta Library and supported by the Alliance, and it allows you to develop a DMP by prompting you to answer a number of key data management questions, supported by best practice guidance and examples. This tool is free to use regardless of institutional affiliation or non-affiliation. And with the DMP Assistant, researchers can create project plans using a generic template or an organization, discipline, or methodology specific template. You can see guidance appropriate to the particular template you're using and your organization, collaborate with multiple researchers on a plan, and connect to local guidance and support for data management at your academic institution or research organization. And if you'd like to try it out for yourself, you can head over to assistant.portagenetwork.ca, where you'll find this landing page. And from here, you can sign on with existing credentials if you have them, or you can create a new account. And if your organization or institution is not yet listed, you're also able to enter your own by selecting My Organization Isn't Listed, seen here. So in addition to the generic default DMP template that's available in the DMP Assistant, we also offer 13 discipline and methodology specific DMP templates developed by the community and comprised of sections, questions, and guidance. And these cover a range of disciplines and research methods, highlighting best practices for those disciplines and providing tailored guidance for writing your own DMPs. And you'll notice I've flagged, we do in particular have a template for water quality, so that may be of interest to the audience today, as well as a mixed methods option. And these templates are all embedded for use in English and French in the DMP Assistant, and they're also available from the Portage website under training resources. And the link is on the slide here. In addition to templates, we also offer 9 discipline and methodology specific DMP exemplars. These were also developed by the community and similarly cover a range of disciplines and research methods. These highlight best practices in those disciplines and provide helpful reference points for writing your own DMPs. And where the templates provided the sections and questions to be answered by researchers accompanied by guidance, these exemplars are actually full examples of completed DMPs, some hypothetical and some pulled from real research projects from the community. And again, I've highlighted a couple of examples that might be of particular disciplinary interest to this group. Finally, you can also browse our available webinars and tutorial videos on DMPs. These include 2 webinars delivered last year on the topic of supporting your research with DMPs and with the DMP Assistant, as well as a brand new set of 3 DMP tutorial videos that provide an introduction to DMPs, an introduction to the DMP Assistant, and guidance on how to manage existing DMPs within the DMP Assistant. And many of the resources I've covered in these last few slides are also available from the training resources page of the Portage Network website. And that's the link I can add into the chat once I've concluded here. So with DMPs covered, I'm now going to pass things over to my esteemed colleague, Tamanna, who is going to take you from planning through to active data management.
Thank you, Robyn. Apologies, my camera has been acting up. Okay, hopefully this works perfect. All right, hello everyone, I'm Tamanna. I'm a data curator at Federated Research Data Repository, or commonly known as FERDR, at a Digital Research Alliance of Canada. Well, now that we have walked through the planning process with Robyn, let's work the plan, because as we know, planning is something, but there is reality. And to do that, we need a little thing called active data management. In the next slides, we are going to speak to some practical tips that can help you manage your data throughout the project cycle. There are a set of good data management practices that researchers can adopt regardless of their data management skills and level of expertise. Before we dive into the practices, let's talk a little bit about benefits of active data management for you, the researchers. To start with, and I'm sure Nichole and Robyn has really drilled it into you already, but it fulfills the tri-agency grant and responds to publisher requirements. Many of the journals are now asking researchers to deposit data in a repository. It will ensure your data is accurate, complete, and most importantly, reproducible. With active data management, your data is FAIR compliant, so it will improve discoverability of your research and also save your time and resources in the long run. It also enhances data security and minimizes the risk of data loss. Now that we know active data management is such a great idea, you might be thinking, how do I get started? Sometimes it can be confusing to know where to start, what questions to ask, where can I share my data, or should I be preserving my data? Getting in touch with your local RDM librarian or repository staff, hint, hint, can help you get started. You know the story of your data best. And while we can't cover everything in a 15-minute presentation, we can give you some guidelines and recommendations to get you thinking. This slide has some examples of conversation starters relating to data management activities, such as creating good documentation and metadata, data sharing, looking ahead to long-term preservation that can help you tell the story of the evolution of the resultant data set. Knowing what elements of the story need to be told in the end can help and implement your DMP. We'll be covering some of these activities in more detail. Begin with the end in mind and plan how to get there. First up is documentation. Remember the commonly asked question to the IT team and their famous answers? Have you tried turning it off and on again? Well, this is the RDM version of the answer. README is a very resourceful piece of document, which is a means for the researchers to provide the additional information that is uploaded alongside the data set. While it isn't searchable, it's really important for context. It's a way to give the next researcher a quick debrief on what they're looking at. Having accurate, up-to-date documentation is especially important for understanding context and relationships over time. It can be overwhelming to put together README or other descriptive documents at the end of a project, but you don't have to start from scratch. Think about what information a new researcher joining your team would need to know in order to understand the work. You may find you already have the information you need spread out in other documents, such as research group website or a wiki or a data management plan or publication related to the research. And there are a number of templates and checklists that can help you to get started, two of which are linked in this slide. Next up, file organization. This is the scaffolding of your data files. The structure you choose will largely depend on what makes sense for both your project and the way you work. So you might choose to organize by file type, by site location, by the particular analysis, or any other manner. Most systems have a maximum path length that they will allow. So try to keep your folder name short but descriptive and avoid using any special characters or spaces. Tier protocol was developed for social scientists who were interested in reproducibility, but it is applicable outside of that discipline. Even if you aren't striving for reproducibility per se, tier protocol might help you get started as you think about how to structure your data files and what types of documentation and other information will be necessary to keep your data useful in the long term. At the project tier website, each item in the file structure is hyperlinked, and you can click to see further details about the type of information that should be included. Similar to directory names, try to avoid using spaces or special characters, which are handled differently by different operating systems and can cause trouble on the command line. That's not a pretty picture. Avoid information that is potentially sensitive in file name, such as names or initials of human participants or protected site location information. Instead, use a code or ID and maintain a separate key file for that information. Further information about the file organization is available from the University of Ottawa Library, along with the guidance for naming files. Ideally, file name will provide information about the content of the data file. Try to use descriptive names, but keep them short. You can abbreviate information in your file names and define it in your documentation. If you use dates, record them in the ISO year, month, date format so files can be sorted chronologically. And lastly, if you will be storing multiple versions of a file in one directory, use a date and/or a version number rather than a descriptive word like final, which could easily lose meaning if you make further changes. A file naming convention can be a practical and a simple way to keep track of your materials, their version, their uses, etc. So imagine what it can do for someone who would like to reuse or access your data in 10 years. Next up is metadata. Metadata, simply put, data about data. It is the structured information about an information resource that describes, explains, locates, or otherwise make it easier to retrieve, use, or manage that resource. And there is no way to manage research data without good metadata. I'm going to go briefly through some of the key metadata elements and things to consider when you're creating metadata for your data. One of the most important elements is the description. You can think of this like the abstract for your data set. It can help others to find your data set and then decide if it's relevant, what they're looking for, to decide whether they want to download or view your data or dig deeper. Sometimes we see researchers copying over the abstract from their paper to the dataset description. This isn't ideal because the paper abstract describes a different research object and because the data can be used for future inquiries that aren't related to that first paper. So you want to write a unique description of the dataset itself, not just use the paper abstract. When you're writing a data description, you'll want to keep in mind that the goal is for others to find your dataset and put yourself in the shoes of someone finding your dataset for the first time. Another important metadata element is subjects or keywords. What you choose for subject terms will depend on the repository and your discipline. The repository may provide a list of terms to choose from, or there may be commonly used vocabulary in your discipline. If the choice is left open-ended, a good rule of thumb is to think about what keywords you would normally search with. Again, putting yourself in the shoes of someone who might want to find your data. Finally, although there are many more metadata elements, the last one I want to touch on is geospatial metadata. Even if your data aren't explicitly geospatial, it can improve discoverability to include this information. If your data in any way is about a place, depending on the repository and metadata schema, you may be able to provide place names, latitude or longitude coordinates, or a bounding box defining the area your dataset is about. If there are no specific fields for location information, it is also possible to put a place name in the subject field as an alternative. You will want to consider what license you want to apply to your data. The license communicates how your data can or cannot be reused. If you're using data provided by a third party or obtained from a repository or the web, there may also be restrictions on the use. Remember that free to use does not mean free to redistribute or to republish. If you can't find an explicit set of terms of use or a copyright statement assigned to a text, image, or data set, it doesn't necessarily follow that there are no restrictions on use. Your library should be able to help if questions arise, as should repositories from which you have downloaded the data. Don't hesitate to reach out if you need clarification on how a particular data set can be used. Keeping good track of your data sources from the outset and the terms of use assigned to those sources will make it easier to know whether you can share some or all of your data later. For those data sets or research outputs that are made available under a CC0 license, public domain dedication, proper attribution is still recommended. Attribution is a good practice in general, and even if it's not explicitly required by the license or the terms of use, this is a good scholarly practice and helps demonstrate the value of data. Here are a few examples of the metadata standards commonly used by researchers working with water data. If there isn't one for your field or your data type, you can still borrow elements from existing standards or create your own standardized way of recording data. Next up is preservation and data sharing. Preservation is a series of managed activities necessary to ensure continued access to digital materials for as long as necessary. It can be defined by short-term, medium-term, or long-term goals. Preservation is often seen as an afterthought, but there are many benefits to thinking about it in the planning phase and allowing that to shape how you manage data throughout the research project. Now, sharing and preservation might not be your end goal, or you might want to share your data, but what you can share is limited by a research contract you signed or for any other reason. But the activities we have described can help keep your data useful to you and accessible by you in the short and medium term. You're still responsible for your data, no matter where it resides. Transferring stewardship or care of your data set does not typically take away any rights or relieve you of any responsibilities. Some of the responsibilities are you will remain the recognized and attributed creator of the data set, the contact person for your data set, or the person you named will remain the contact person. You can deposit a new data set or a version, the old one. If necessary, change the license, even reuse your own data set in future work. But any changes should become transparent to future users once published. To help ensure your data remain accessible, choose open or non-proprietary file formats when possible. Example, plain text file, CSV, JPEG or TIFF for images, NetCDF and HDF5 for multidimensional data. If you need to keep your data in a proprietary format for analysis, consider transforming a copy into an open format that will allow long-term access if software changes and is no longer backwards compatible. Secondly, choose an open license that will allow for access and reuse. And finally, make sure your data are well documented. Give context to the data by adding a README or codebook or any other documentation, and linking out to publications or other external resources that provide context. Now that we have covered what sharing and preservation is, where to deposit. There are many data repositories out there, and each one has a different scope, which you will want to consider when deciding where to deposit your data. Some repositories are domain or discipline specific and will only accept data related to that specific discipline. Others are more general and do not have domain restrictions. Then there are some repositories that are associated with specific institutions and require that a researcher be affiliated with that institution, whereas they may have a national or international scope. One other key consideration is how much data you have. Many repositories have restrictions on the size of your data deposit and are only few are equipped to handle large data sets. Now to recap, follow best practices guidelines to name and structure files. Create a README, a codebook, and other documentation necessary to understand your data and interpret it correctly. Document data collection instruments, methods, quality control measures, specialized software needed to view or manipulate your data. Describes the contents of your directories and or files. Write a unique description of your data set and choose keywords that will improve discoverability. Provide attribution to any external data sets. Select a license that respects the constraints of any data you may have reused. In this slide, we have linked to a few resources here that may be helpful if you want to take a deeper dive into some of the topics. And I do want to emphasize that librarians at your institution, both subject-specific librarians and data librarians at your institution, are an invaluable resource. The Alliance RDM team maintains a list of institutional RDM contacts, which is also linked here. Thank you for attending our presentation. Hope you have found some useful takeaways. And if you have any question, our team is happy to answer them or to link you to the appropriate person at your institution. So please don't hesitate to reach out. Thank you.
Thank you so much for your presentation, each of you, but Tamanna, thank you for bringing up the end. And I'm just wondering if anyone would like to ask questions. There's a chat Q&A. There's a Q&A box that you can ask questions, and then there's also the chat. So now's the time. And also, I think you should be able to put your hand up and we can allow you to talk if you'd like to ask your question. So there was a lot of information there. I guess I'll just have one question. If someone did want to go to Portage and sort of sign in and start looking around, like maybe starting to put together the DMP. Could one of you just talk about the process of that, just briefly, what the steps are for someone to go in there and start?
Yeah, you're referencing the DMP Assistant platform specifically? Yeah, for sure. Yeah, so I flashed on the screen there. If you go to assistant.portagenetwork.ca, that brings you to the landing page of the DMP Assistant. So if you already have an account, obviously you just sign in, easy peasy. There's the create account option secondarily along the left-hand side. So there you can create an account and you can affiliate yourself with your research organization or your institution if applicable, but you also have the option to sign up. And if your organization isn't listed, then you can enter your own. So it's really free to use regardless of affiliation or non-affiliation if you're more of a freelance individual. So once you're logged in, you'll be brought to your dashboard, which is the kind of the core of what you're able to do in the DMP Assistant. And from there, you can create a new plan. And from there, you'll be asked to give it a title, choose the primary research organization that plan is, or that project is most closely related to. And this doesn't even necessarily have to be the organization that you affiliated your account with. It can be, if you're doing research for other organizations, you can choose your template or associate your plan accordingly. And depending on which institution you chose, you'll then have a dropdown of template options. So as I mentioned, there's a default or generic DMP template it's kind of a one-size-fits-all option. It really is fairly flexible and should cover the bases for most research, but you can also further specify based on your discipline or your methodology. So we've got, I think it's a total of 13 discipline and methodology specific templates to choose from. And additionally, if your institution that you've chosen has chosen to create their own institutional templates, you may see some other options depending on the organization or the institution that you've chosen. And from there, you'll be walked through adding administrative details for your project, and then through sections and individual questions, you'll be prompted to answer a series of questions, invite collaborators if you'd like, and then when all is said and done, you can export it in a variety of file formats to suit your needs. So that's kind of a quick and dirty high level description of what you can do, but some of the tutorial videos I pointed to in my presentation should give you a more detailed idea of that process. But yeah, hopefully that's should get you started anyway.
Okay, great, thank you. Thank you, Robyn. So I'm not seeing, unless I'm missing, I'm not seeing any more questions. So I think we might move on to Shen sort of doing a final thank you and closing of the webinar. And I just wanted to say again, thank you to each of you for attending and doing your presentations.
Yes, thanks, Alexi, and thanks, Robyn and Nichole and Tamanna. It was great to learn all about the Digital Research Alliance of Canada. I think it was really valuable information. I really enjoyed it. And then thank you everybody else for joining us today. If you do have any further questions for us, you can contact us at any of the outlets listed here on our website, email, or Facebook or Twitter. And this is the final webinar in our Coastal and Ocean Best Practices series. Now we will be writing a Coastal and Ocean Best Practices guide specifically geared towards ENGOs based off of what we've learned in our 3 sessions here, which were Suez Atlantic, the Ocean Biodiversity Information System, and the Digital Research Alliance of Canada. So once we finish that, we will be happy to send it around to all of our participants and organizations that have been involved in this project. So yeah, that's all of the updates that we have for you. I hope you have a great rest of your day.